Hello class, so in this video we will be talking about the second of a bunch of convergence tests called the alternating series test. So let's look at what it says. So let's just say S is this sum. So if A sub n is positive, increasing, and converging to 0, then S converges. So let's check why this works. So there are a few basic reasons why. So let's just look at S itself. It'll be A1 minus A2 plus A3 minus A4 infinitely, right? So let's consider the partial sum S sub n and let it be this. Then we can see that S sub 1 is just going to be A sub 1. S sub 2 is actually going to be S sub 1 minus A sub 2. Okay, so that's interesting. S sub 3, if we add that together, we can notice that it'll be S sub 2 plus A sub 3. And if we go further, we get basically S sub 3 minus A sub 4. And you can just kind of see that whole pattern going on. So that means for odd numbers, notice that even numbers you're going to be subtracting, and then odd numbers you'll be adding. So you'll see some interesting things like that. So I know this might be a bit abstract, so let's just look at an example of this, or an illustration of this that is more visual. That way we can understand it a bit better. Okay, so say that that's 0, and then we go to S1. Okay, so that's going to be some value here, right? So the distance here is going to be exactly just A1. Okay, and then if we go to S2, that means we're going to go backwards and be somewhere like this. And then there's a distance between that. Basically, how did we get there? How we got there was subtracting A2 from that whole thing. All right, and then let's go further. S3. And how do we get there? We add A3. And you can probably start to see what's going on here. I'm going to draw a little bit more, and then you'll start to see a bit more of a pattern as well. There's a pretty useful pattern here. So notice the thing I'm doing in the middle. This is basically S. Right, S5. Notice, same pattern, same type of thing going on. And one more, and then we should start to be able to see some stuff. Some interesting stuff. So that's S6. That also is when I ran out of space. So as you can see, this whole idea is going to continue on, right? Kind of like that, just infinitely. So what do we notice about the S1s? So this is assuming that the thing is that A sub n's are getting smaller and smaller. Well, S sub 1, S sub 3, S sub 5, they're going that way. Let me use a different color. They're decreasing, but getting closer and closer to S. And then the even numbers, so like S2, S4, S6, they're increasing, but getting closer and closer to S. So when we have this sort of thing going on, that's basically what happens. So the odd partial sums decrease towards S. Sorry, I think I meant to put more space there. I'll just edit that real fast. Toward S. Not towards. Toward S as n approaches infinity, and even partial sums increase toward S as n approaches infinity. So again, this is only because of the fact that the thing is decreasing. Alright, so when do you use it? Well, basically if the thing is alternating, so if a sub n itself here is alternating, and then b sub n, I just introduced a different little thing. So basically that little sequence inside of there after the alternating part, if that's decreasing and converging towards 0. So let's practice and see what happens. Alright, so we can see that this is alternating. Let's see if it converges to 0 and if it, what is it? Decreases, sorry. Okay, so we can look at this a few different ways. Well, for one thing, we can see if the limit is going to approach 0 or not. So from this, you might be able to start to see that actually this approaches 2 over 3. Alright, that's a bit of a red flag. That means we can't really use this. Does this necessarily mean that the divergence test comes into play? Not really, because you need the whole thing to not equal 0. But that gets complicated. So let's look at to see if this decreases or not. Basically, this is a function. 2x over 3x plus 4. If we find its derivative, we can know for sure if it converges or not. Or if this decreases or not. Alright, so bottom times the derivative of the top minus top times the derivative of the bottom. All over the bottom squared equals 6x plus 8. Whoops. Minus 6x, all divided by this thing. So we end up with 8 over a thing with a square. So this is always positive. So that means this thing is actually always increasing. Therefore, the alternating series test tells us absolutely nothing. It doesn't tell us if it's going to, if the series will converge or not. It also, yeah, so this is inconclusive actually. So I wanted to use this one to show an example of when this would be inconclusive. So let's try something else. Or let's not something else. Let's go to the next one and see how that works. Okay, so this is clearly alternating. So let's check the limit of that part in there. And since you're probably familiar with limits, this pretty obviously will approach 0. So that works. And now let's check if this thing is decreasing or not. So write it as a function so that we can take the derivative. Alright, f prime is going to be bottom times the derivative of the top minus top times the derivative of the bottom, all divided by the bottom squared. Okay, let's see. So that's going to give us a 2x to the 4th minus 2x minus 6x to the 4th. Yes, 3x to the 4th, sorry. All over this thing squared. Okay, so let's see. That's going to be negative x to the 4th minus 2x. All divided by x cubed minus 1 quantity squared. Okay, so when is this negative? So let's just set this equal to 0, find the critical points. So that'll be let's see, x equals 0 and x equals the cube root of 2. Okay, cool. So let's see, if we were to look at this, just on a quick little number line there, 0, cube root of 2, whatever that is. Let's check things. So essentially, if from this point on the thing decreases, then it's going to work. Okay, so let's see if we do that. We know that the bottom is going to be positive no matter what. So let's just take this factored form and plug in something that is in this range. We don't care about any of that. Okay, so let's see. Let's just plug in like 10 or something. If you put in something like 10, then we'll get negative 10 times... Okay, 10 cubed minus 2 is obviously going to be something positive. So we get something negative, therefore the thing decreases there. Therefore, yeah, so decreases on cube root of 2 to infinity. Therefore, by alternating series test, this summation converges. Alright, so that will be the end of this. Hopefully that was helpful. First thing of many convergence tests. So I will see you all in the next video then.